Welcome to today's lesson on set theory. We will be verifying a specific case involving sets U, B, and C. Let's define our universal set U. U equals the set containing 1, 2, 3, 4, 5, 6, and 7. Next, we have set B, which contains 2, 4, and 6. And finally, set C, which contains 3, 4, 5, 6, and 7. Now, we will find the intersection of sets B and C. The intersection B intersection C consists of elements common to both sets. Thus, we calculate B intersection C equals the set containing 4 and 6. Next, we will find the complement of B intersection C. The complement is defined as U minus the intersection. So, we have U minus the set containing 4 and 6. This results in the set containing 1, 2, 3, 5, and 7. Now, let's calculate the complements of sets B and C separately. For set B, we calculate U minus B, which gives us the set containing 1, 3, 5, and 7. For set C, we calculate U minus C, which gives us the set containing 1 and 2. Now, we will find the union of the complements B' and C'. B' union C' equals the set containing 1, 3, 5, 7 union with the set containing 1, 2. This results in the set containing 1, 2, 3, 5, and 7. Finally, we compare our results. We have found that the complement of B intersection C equals the set containing 1, 2, 3, 5, and 7. And we also found that B' union C' equals the same set. Therefore, we can conclude that the complement of B intersection C equals B' union C' is indeed proven. Thank you for joining us in this exploration of set theory. Remember, understanding these concepts is key in mathematics.